We have seen about the basic concepts of friction in the last class. Now we'll see about the laws of dry friction and how the coefficient of friction is need to be calculated. Let's see the image. In the image, it is given that a block is in the stationary condition on a table. If we want to draw free body diagram for this particular block, the self weight of the block acts perpendicular to the ground plane. Then the reaction force acts perpendicular to the lying plane. This is the self weight. The block is in static condition. There is no frictional force acts on that image, first image. When we start applying a force on the right side of the block, so left side of the block starts moving towards its pushing direction, so that the frictional force occurs at the point of contact surface. That is the block between the block and the table. The frictional force will occur over there. It moves opposing to the applied force. This is how we have to draw the free body diagram. The other two forces which we already drawn already, the block is perpendicular to the self weight of the block is perpendicular to the ground plane, and the reaction force is perpendicular to the lying plane. It remains same. This is how we have to draw the free body diagram. This frictional force is directly proportional to the coefficient of the friction and the normal reaction. This coefficient of friction decides whether the object need to be in rest or the object need to start impending, that is about to move, or it is in a rolling condition where the kinetic friction occurs. So this coefficient of friction only decides the block either to be in static or in movement or in rolling condition. See this graph. If we apply a force, the object state to be in rest till it reaches its maximum condition. When it reaches its maximum conditions, the frictional force will be lesser than the applied force. Then the body starts moving. This is what that's shown in the graph. Till it reaches the maximum position, the object will be in condition of equilibrium. When it reaches the maximum condition, it becomes static and it starts moving, so that the motion will occur. Let's see the four conditions. Four situations that occur when a rigid body is in contact with the horizontal surface. When the applied force is perpendicular, when the applied force is parallel to the weight, then the object acts towards the gravitational force. There will not be any frictional force. That is the no frictional force will be there. It is the first condition. Here only the vertical forces are acting. So that when we resolve the forces into sigma Fh and sigma Fv, sigma Fh, there is no any applied force, that the frictional force will be of 0. P and W is acting towards the ground plane, that is towards the downward direction. So it will be of minus P and minus W. So N is acting upward direction. So N minus P plus minus W is equal to 0 for sigma Fv. Then equating the N is equal to P plus W. This is the condition 1. When the second condition occurs, an applied force P, it is inclined at an angle. When we resolve it horizontally and vertically, for horizontal it is Px, and when it is resolved vertically, it is Py. The second condition is also there is no motion in the object, so that the frictional force will be higher than the applied force. For the second condition, also it is no motion in the object, so that the applied force is lesser than the frictional force. Here, when we resolve it horizontally, the Px, here the frictional force occurs. So Px is equal to F. F will be lesser than kinetic friction into normal reaction. Therefore, N is equal to Py plus P. The third condition is motion in impending. That is the object about to move. Here, the frictional force is equal to the horizontal force, so that the object starts moving. Fm is equal to P into X. Fm is equal to mu into coefficient of friction. Mu is coefficient of friction into the normal reaction. Here, when we resolve the forces vertically, we'll get the equation as N is equal to Py plus W. Similarly, when the object in moving condition, here the frictional force will be lesser than the applied force, so that the object starts moving. Frictional force is lesser than applied force. That is, applied force is greater than the frictional force. These are the 4 conditions that to be taken in consider to identify the coefficient of friction value. The formula to identify the coefficient of friction value mu is equal to Fm by N.